No, that went pretty well. Now, the only problem I can see at the moment is that our code's going to get pretty repetitive, and it would be nice if we could make this happen continuously without us having to copy and paste this an infinite amount of times. So to do this, we're going to try a new concept called while loops. Now, to do that, I'm going to type, bearing in mind this first piece is just all setting up everything ready to go. When I actually want to start looping and repeating the bit in here, what I'm actually going to do is create a while loop. To do that, we type the word while, and I'm going to say while, well, I could say while all sorts of things, but I'm actually going to do a very simple command, which is while true. This just means always. It's the same as saying while 1 equals 1, because 1 will always equal 1, and 1 equals 1 is true. It means it's always true, it's always correct. 1 will always equal 1, and for this reason, while true just says do this forever. So while true, we would like to turn the Gpio output 11 to be true, so I'm going to indent this section to make this part of the while loop. This is particularly important in Python. So because this is inside our while loop, we just indent it once using the tab key. So we turn our light on, and then we've got time.sleep 3, so I'd like to, do a little delay for 3 seconds. Then I'd like to turn the light off and wait 3 seconds. Now I don't need to turn it on again because I actually just want this bit to keep repeating. So I'm going to delete these 4 lines of code as they're no longer necessary. At this point, I hope that this bit will continuously run forever and we'll have no other problems. So let's just save this up to date. Again, the asterisk tells us it's not saved. I'm going to use Control S. Come back into our terminal window and we'll run the same command again. We can now see that this command is never going to stop running. It's still running, and the flashing will continually go on forever. So what can we do to stop that? Well, we're going to need another keyboard shortcut, and we're going to type Control-C, just like you would use for copying. So Control-C in the terminal window, you'll notice pulls up an error message and stops it running. The key bit to note here is we've got a keyboard interrupt, which is fantastic, and it just stopped that code from running. Now you'll notice if you stop that code from running while the LED is on, it will actually stay on forever. Now this tells us that our Gpio Cleanup piece of code is not running, so our next job is to try and figure out how we can make sure that still works even if we interrupt the code. And the reason this isn't running is because this is constantly looping, so the code never gets as far as the cleanup section. So what we need to do is code in to say, well, if you do get a keyboard interrupt, then please run this bit before you exit the software, and that's what we'll look at next. So to make sure our Gpio.cleanup still executes, what we need to do is add another feature, which is a try except feature. And this basically says, I'd like you to try and run this while loop. However, if we get a keyboard interrupt, which is our exception, then I would like you to do the Gpio cleanup. To do this, we just say, well, try and do this. And because this is the bit we want to try and do, it's inside this try. So I'm just going to indent the while loop inside the try. You'll also notice that these 4 lines of code now need to be indented inside the while loop. So we've got a bit of a hierarchy now, that for example, the Gpio output 11 true command here is inside the while loop, which is inside the try. We also now need to have our except feature, and I'm going to say except keyboard interrupt. If you get the keyboard interrupt, indent, say that's inside that, we would like you to Gpio.cleanup. Please note again the asterisk is there, so we must save up to date. I'm going to use Control S to do that. And if we come back into our terminal and we try running one more time, I'm imagining that we're going to see an error message that our GPIO pin is still active from the last time that we ran when the cleanup wasn't working. So let's just try that now. Yes, we got our error pop up, but now we can see that it is looping, and this will go on forever. And just to check that our keyboard cleanup, our GPIO cleanup is working, let's finish that program. Control C. And let's now try running it again and see if we still get the error message. No, so that shows us that this is working and the GPIO cleanup is working perfectly, which is great.